Welcome to This Explainer. Today, we're going to completely change how you think about machine learning operations. We're talking about taking those chaotic, manual ML workflows and turning them into automated, self-healing pipelines on Kubernetes, all using Kubeflow. If you've ever, struggled to get a model out of a Jupyter notebook and into the real world reliably, well, you are in the exact right place. Picture this scenario. You've spent months, literally months, in your basement experimenting and building this super advanced large language model. It's brilliant. You launch it, people go crazy for it, and it goes viral. But then, boom, you hit a brick wall. How do you actually deploy this thing so it survives the traffic? Because the second millions of people start pinging it, your server crashes under the load, requests start timing out, and your users are immediately complaining. And that brings us to this brilliant quote. ML workflows that live in someone's head and someone's notebooks do not scale and do not survive. It hits the nail on the head, right? Relying on human memory or just a few local scripts and manual clicks to deploy a model, it's a massive trap. I mean, what happens when the engineer who built it goes on vacation? Or the system breaks? Nobody knows which step failed or how to fix it. We absolutely need a better way. So here is our roadmap for today. 5 quick sections: the manual ML trap, Kubernetes and Kubeflow, automating experimentation, orchestrating pipelines, and finally, automated evaluation. Let's jump right in.
Section 1, the manual ML trap.
So what does this manual trap actually look like in practice? Well, you run one notebook to pull your data. Then you run another one to train the model. You manually check the metrics, you manually copy the model over, and then you manually deploy it. But without a system to balance the load or dynamically spin up compute when you need it, that single manual deployment is incredibly fragile. A sudden spike in users, total server crash. It's a workflow that just cannot adapt to business demands. Which brings us to Section 2, Kubernetes and Kubeflow. Enter Kubeflow on Kubernetes. Think of Kubernetes as your data plane. It's the muscle, right? It handles the raw compute, the multi-tenancy, the auto-scaling, and Kubeflow? That's the control plane. It's the brain that's actually managing your machine learning workloads. Together, they create this incredible platform for building scalable, portable ML workflows. And this isn't just theory. Tech giants like Spotify, PayPal, and Lyft are running their ML platforms on this exact architecture. Now, you might be asking, why Kubeflow specifically? Why not Airflow or MLflow? Well, Airflow is great, for sure, but it's really built for general data engineering and ETL. MLflow is awesome too, but it's heavily optimized for AWS. Kubeflow, though, is literally purpose-built and ML native for Kubernetes. That means you get built-in artifact tracking, experiment comparison, and all those crucial model-centric features right out of the box.
All right, Section 3, automating experimentation.
Finding the perfect hyperparameters can literally take weeks of manual guessing and checking. It's brutal, but Kubeflow solves this with a powerful component called Khatib. A Khatib experiment is basically a complete hyperparameter tuning job. And the coolest part, it automatically coordinates these trials to run in parallel across separate Kubernetes pods. It logs all the parameters, all the metrics. You don't have to manually track a single thing. The system handles the whole shebang. The real trick here is picking the right search algorithm for what you're doing, and Khatib gives you 4 main options. You've got random search, simple, but it doesn't really learn from its mistakes. Grid search is thorough, but man, is it computationally expensive. Hyperband is fantastic for quickly tossing out poor performers. But Bayesian optimization, that's the really smart one. It builds a probabilistic model and intelligently uses past trials to pick the next parameters, meaning you converge on better results way faster. To really see how efficient Khatib is, think about a simple math test, like optimizing a function to hit the target number 80. Khatib seamlessly spins up those parallel pods and pinpoints the exact parameters, say A equals 20 and B equals 0.1, in no time. Validating this cheaply on a simple function gives you the confidence to unleash it on the big stuff, like a really expensive, complex logistic regression classifier for filtering SMS spam. Moving right along to Section 4, orchestrating pipelines. At its core, a pipeline is essentially a directed acyclic graph, or a DAG, of steps.
The absolute beauty of Kubeflow is that it reads your pipeline definition and figures out the exact execution order based entirely on data dependencies. So if your train step needs data from preprocess, Kubeflow makes sure preprocess is totally finished first. You never have to manually specify what runs when. The data dictates the flow.
And every single step in that DAG is a component, which you create just by decorating a standard Python function. In production, every component acts like a sealed room. It runs as a fully isolated unit inside its own specific container image. This means Kubeflow acts as the ultimate glue. You could have one component pulling features using Feast, and the very next component training a model and logging metrics natively over to MLflow. If one step breaks, it doesn't corrupt the others. Total fault isolation and total reproducibility. Finally, we reach Section 5, Automated Evaluation. So how do we guarantee only the good models actually make it to production? We use an evaluation gate component. It's super elegant. You write a component that takes your training metrics as input, checks them against the threshold you set, and spits out a simple Boolean, true or false. And that Boolean controls everything. If it's true, the pipeline triggers deployment. If it's false, it completely stops. We are entirely removing human dependencies here. A bad model gets stopped in its tracks, no manual dashboard checking required.
Okay, so how do we bring all of this to life? Here is your execution timeline. First, you write and decorate your Python functions. Next, you compile that code into a portable YAML artifact. This is basically the blueprint of your entire pipeline. Then, you submit that YAML to your cluster using the Kubeflow pipeline client. From there, Kubeflow takes the wheel. It reads the YAML, spins up the necessary pods, passes data between the containers, and you just get to sit back and watch the live progress right in the UI.
Now, before you run off and build your own pipelines, you absolutely need to memorize these 5 production best practices from our explainer today. 1. Always pin your base images and package versions, literally crucial for reproducibility. 2. Keep your components small and single purpose. 3. Always use an automated evaluation gate before deployment. 4. Version your compiled YAML files in Git right alongside your code. And 5. Use pipeline parameters so your workflow stays dynamic and reusable. So we've built this incredibly automated, self-promoting system. You can even set these Kubeflow pipelines to run on a recurring cron schedule, automatically pulling fresh data and retraining every week. But I want to leave you with this provocative thought. Your pipeline is automated, sure, but what happens when the real world changes and your underlying data drifts? How do you build a system that detects that drift and automatically triggers this beautiful pipeline to self-heal? Well, that is the next frontier of MLOps. Thanks for joining me for this explainer, and keep exploring.